Hey guys, it's Dr. Rones here. We are going to simplify linear expressions today by combining like terms. This is a continuation of objective 28. 28 and 29 go together. What are you tapping on, honey? I'm sharing your sloth with the kids. Yeah. We thought it'd be a good idea to start with something fun. This is my little boy sloth, and he's standing here because he wants you to see it. All right, they're gone. My kid and the sloth, they're watching football. Okay. So where was I at? This goes with distributive property. Oftentimes with a distributive property, it produces multiple terms with a variable or multiple terms with just a constant. These aren't vocab words that you have yet, but we can use combining like terms to make those expressions a lot simpler. Before we do that, we do need to make sure, again, that we have the right vocabulary, that we all understand what people are talking about. We're going to bust through some what ifs, and then we will actually start the task of combining like terms. Okay. So remember from objective 28, when it's tough to tell where a sign goes, you can find a sign, draw a line to the left so that you can see what the chunks are, or the terms. So negative 21W is a term, 5 is a term, 3Ws is a term, negative 1 is a term. So when we're asked the terms of an expression, we can just list them out and separate with a comma. You don't need to write the positives for the positive ones. Just list them out like so. Now, like terms are the two terms that have the same variable. I understand that two terms may be similar, that they don't have any variable at all. So like 5 and negative 1 are similar because they have no variable with them, no W, but they are not like terms. In order to be a like term, you need to have a variable, and it needs to be the same as a different term. So negative 21 W's and 3 W's, and we just list them like that. Okay, coefficients. Co is a word that typically means with. So if you are on a team and there's a co-captain, there's two people who captain together, or co-teachers, or two teachers who teach together. So co means the number with the variables. So in this case, it would be, there's the W, negative 21. Here's a W, the positive 3. So we just list out negative 21 and positive 3. And then finally, at the end, we list our constants. The slang for this up to this point has been the naked numbers. I don't know why that's a phrase that just sticks with people. It's silly. But I guess if it works, we're going to keep on going with it. But now we can call it a constant. We call it constantly alone because it's naked, which is weird. I don't know. So the constants here are 5 and negative 1. Okay, great. So let's do some what ifs. There's going to be some different situations that come up that might throw you off a little bit. I'm going to divide up my terms. You don't have to if you don't need to, but sometimes it helps kids. So my terms here, you can list them out, are 13x, 7x, negative 6. Again, you don't need the positives in front. My like terms, I have an x here and an x here, so 13x and x, so not 7 and 6. Sorry, 7 and negative 6, not those. Coefficients will be 13 and Okay, so here I have an x, but no number with it. So what would be the coefficient? Would you say 1? Great job. It is not 0. Some people think it's 0 because there's no number there, but it's an invisible 1 because it's 1x. So 13 and 1. And the constants, the numbers that are alone, are 7 and negative 6. Please make sure you remember your signs, because there is a big difference between, say, positive 6 and negative 6, especially if it's your money. It's much more fun to find $6 in your pocket than to lose it out of your pocket. That's a bad day. All right, let's list out our terms. 2x, -7, 3y, and -5. That one wasn't so bad. Okay, our like terms here. We have an x and a y. Uh-oh. Okay, so these both have variables. They're alike in that way, but they are not the same variable. So here, I don't have any like terms. So when that happens, please don't leave it blank. That doesn't indicate to me that either you know it or you don't. Please don't write 0 because 0 is a number. Okay, you can write the word none, and that will tell me that you understand that there are no like terms there. Okay, list out your coefficients, please. 2 and 3. And your constants are -7 and -5. All right, good job. Keep on going. Here we have 4 terms, right? 1, 2, 3, 4. Let's write them out. 6m, -2n, -4m, and -8n. Lots of negativity in that one. And now our like terms. So we have m and m. Oh, but we also have n and n. So we have 2 sets of like terms. When that happens, you can put the like ones together, so 6m and -4m, and then separately list -2n and -8n, or you could separate it with a line like so. Don't just list them all together, because that would imply that these m's are similar, or that they are like terms with n, so separate them out. Okay, now our coefficients. 6 and -2, -4, and -8. Good. And then our constants. Uh-oh. I don't see any constants. Well, don't leave it blank. And don't write 0. Write the word none. Good job. Okay, so now that we have our terminology down, we're going to flip this over and work on actually combining like terms. All right, here we go. We are going to simplify some expressions that don't involve the distributive property before we simplify expressions that do involve the distributive property. Again, you can find a sign, draw a line to the left if you'd like. I like to do that so that my eyes can see what sign goes with what. But if you don't need to do that, again, you don't have to. Remember that when you are finding your solution, the variables come first. And when you have a choice to make, the variables should go in alphabetical order. Okay, and so let's jump in and see how we do. So if I have 9 A's and 3 more A's, 9 apples and 3 apples, that's a total of 12 A's, 12 apples. Okay. If I have 8 B's and then -13 B's, how many B's do I have? -5 B's. Now this is confusing for some kids because we've just come from distributive property, where we do a positive times a positive is a positive, negative times a negative is a negative, negative times a positive is a negative, and so forth. Multiplication is different than addition and subtraction. Addition and subtraction, think of a number line, not multiplication. So this worked out to be a negative, not because I was combining a positive and a negative. This became a negative because I started with -13 and I only added 8 back, so I didn't get back to the positive side. Okay, there is no shame in writing for yourself, if you need to, a number line that you can use. If I have 2 C's, so here's 2, less 3, 1, 2, 3, that's -1, and 2 more back, I'm left with 1 C. You also don't have to do these in any particular order. You don't have to go left to right. So it might be easier to say 2 and 2 make 4, minus 3 is 1. Also, a subtle difference here is if you have 1 anything, just write the variable. 1c is the same as c. This is the more mature way to write your solution. Okay? All right. If I have 2 donuts and 3 more donuts, I have 5 donuts. And then negative 4. This constant does not get combined with the variables. Okay, good job. If 6 elephants ran away and 4 came back, I still have 2 negative elephants. 8 minus 4 is still positive 4. Okay, good job. If you'll see, oftentimes when I'm doing this, I'll underline as I go so that I can make sure that I don't miss anything. So for example, if I have F's, if I have 6 frogs, 2 more frogs, that's 8 frogs, and 3 die, or jump away, or something, I have 5 frogs, and then negative 8. There you go. All right. Sometimes we have different variables together, so we have G's and H's. Which one comes first in the alphabet? G. Maybe you have G. Okay, so I have negative 5 G's, and add 4 back. That's negative 1 G's. 11 H's and 3 H's are a positive 14 H. What do you think I should do there to make that in a better form? Yeah. Negative G plus 14 H. You don't need that negative 1 in there. Kapow. Okay. I'm going to add my lines. A lot of times I don't need them for distributive property, but when there's so many terms, I find it helpful. You might disagree, and that's totally fine. You don't have to do it.
Do not hammer my phone.
Oh my goodness. My little boy is giving my husband a run for his money. Okay. I have I and J here. A, B, C, D, F, G, H, I. Let's do the I's first. 7 and 3 make 10. Oh, and 10 go away. So how do I have? I have no I's. Oi. 4 J's and 3 J's are 7 J's. Well, what can I do to make this even more simple, since this is a lesson on simplifying an expression? If I have 0 of anything, I don't need to write it. So I'm just going to write 7 J's. And that will be my final answer. Good work. Okay. Negative 9m and add 8 back is still negative 1m. 2n, 4n is positive 6n, and a 3. What's something I should fix there? Yeah, that should just be negative 6n and 3. No 1 there. Okay, good. All right, now we have the same variable, but different exponents here. I'm going to zoom in because exponents are kind of hard to see on the video here. Okay, so we are going to go in descending order, starting with the highest exponent. So the highest exponent here is 3. So here's a cube term and another term with cubes. So 8 minus 6 is 2x cubed. Right, 1 step down from a cube is a square. Only 1 squared term, so negative 4x squared. Okay. Now we have the x's, so 6 minus 8, oh, I'm in the negative. And then the constants, negative 7 and negative 1 is negative 8, plus 5 back, still negative 3. Good. Try the next one. The highest exponent here is a 4. There's a 4th power. There's a 4th power. Negative 5 plus 2 back is negative 3x to the 4th. Then we go to cubes. Negative 9 plus a single one is negative 8x cubes. Now we have our squares. 6 minus 6 is 0. And then I have just a regular x. So negative x, and then our plus 2. Okay, and what's something that I can lose there? This, I don't need that. So negative 3x to the 4th minus 8x cubed minus x plus 2. So this would be the correct value, but our goal here is to write it in the most simplified way. So if we can get rid of it, then we do. Okay, so now we are going to, we are going to put all that we've learned with both distributive property, hopefully that was a refresher, and combining like terms all together. And so let's see how we do with that. Trying to make it so you can see a little bit better here. Okay, so let's first do our distributive property. So, sorry, my paper is running into my tripod. Okay, much better. Woo, blurry. There we go. Okay, here's our parentheses. They go with a negative 8. So negative 8 is being distributed to everything on the inside. So this becomes negative 8p minus 48. The other part, the negative p plus 1, they just come down. Okay, so now we have a long expression to represent our expression after the distributive property. And now we can combine our like terms. So if I have negative 8p minus another p is negative 9p. Negative 48 and 1 back is negative 47. And remember, the variable comes first. Okay, so here I have negative 9, see? Negative 9 is being grouped with 11 and negative q. And the other parts are just going to come straight down. Now, you can either do the variable first or you can do this first term first. It doesn't matter because we're going to have to combine it with this anyway. So negative 9 11s is negative 99. Negative 9, negative times negative is a positive. 9q. That's kind of confusing. Maybe put a hook on your q so you can tell the difference between. And so this comes down. Great. And now we can combine. Variables come first. So negative 12. Add 9 back is negative 3q's. A positive 3 and a negative 99 comes out to be a negative 96. Great. Okay. At any point, you can pause this and see what you can do independently, and then hit play again, and I can run you through your solutions to see if you are correct. It's actually preferred because it forces you to think independently. Remember again, you can chunk these up if you need to. All right, and again, I recommend that you mark things as you go so you don't forget them. So let's see, 14 race cars and 2 race cars or 16 race cars. Negative 6 and 4, negative 2. Good. Okay, keep on going. We can do this. So as we go, none of this is going to be any different. It's just a lot of practice of the same thing. So again, feel free to go ahead. 3 times 4 is 12 W's. 3 times 2, 6 U's. All of that was positive. Makes things a little bit easier for us. Bring down what's left. Ooh, what kind of 12W do I have? That's positive, right? Okay. And then U's come before W, I think, U, V, W, yep. So -6 and +6, that's 0. And positive 12W. But we don't need this 0 anything. We can just keep the 12W. And that's good enough. Here's our distributive property moving backwards. So 5 -2's is -10V and 5 x's. Bring down the -12V. They don't have anything to do with that. All right, which comes first in the alphabet? I think it's V. V, W, X, yep. So -10 minus 12, so this is two negatives. We're going more to the left on the number line. It's not a negative times a negative. It's a negative subtract a negative. 22 V's. Then add a 5x. Good. All right, try the next one. Where does this negative go? It goes with the 8, doesn't it? So -8 times 2 is -16 z's. Negative times a negative is a positive. 8 times 3 is 24. Again, a negative times a negative is a positive. That was multiplication, so that's why that became positive. Okay, and now I have y's first. 7 of them, and 24 of them are 31. And then z's. And there you go. Okay, let's make it a step tougher. Okay, here's a new way of writing distributive property you may not have seen before. So here is what's being multiplied, and here is what it's being multiplied by. But the trouble is, if there were no parentheses, this would look like 8 minus a subtract 3. But when it's put together with no sign in between, that is multiplication. So this is for distributive property. -3 times 8 is -24. Negative times a negative is a positive 3a. Everything else comes down. Good. I'm going to do this because that's a lot of terms. Boom, boom. Okay. So if I have 3 apples, 6 more apples, I have 9 apples. Let's see, 10 rotten bananas. And then -24 plus 12 back. So this is not a negative times a positive is a negative. It's a negative, add back a 12. Think of a number line. It just happens that it's still negative. Okay. All right. Again, feel free to pause, do what you can, then hit start again. So it forces you to try to do this independently. All right, so 2 groups of C plus D is 2C and 2D. Everything else comes down. Uh-oh, what goes between this D and 2C? Yeah, it's a positive. Okay. Ooh, my eyes. Okay. A, B, C, D. Let's do the C's first. All right. If I have 2 cats, and one runs away, and another one runs away, I have no cats. Some people wouldn't have a problem with that. And then I have 2 dogs, and another dog. It's 3 dogs, and one of them runs away. Sorry, that's kind of sad. I hope your dog doesn't actually run away. And what's the most simplified form of that? 2Ds. Great. Okay, keep on chugging. We got this. Okay, positive 4 goes to e and the negative 9, so it becomes positive 4e and subtract 36. Everything else comes down. Unchanged. It's not even a part of that. And so, our variables come first. So, all right. If I have, let's see, 12 elephants run away, 4 come back. Sorry, it's always elephants. I should probably be a little bit more exciting than that. I don't know. So let's see, negative 12 plus 4 back is negative 8. There's another one. So negative 7. E's. Negative 36 plus 30 back is negative 6. Variable comes first, and that's our final answer. Good. So as you can see, it's really important that you do your distributive property accurately, because if you come up with the wrong line here, then everything's going to get goofed up, right? All right, only the negative is going to be distributed here. If you want to put a 1 in there, you can. So positive 3f becomes negative 3f. Negative 7 becomes positive 7. This comes down. Okay. Let's see, if I have 6 French fries and I eat 3, I have 3 French fries left. 7 and 1 make 8. Let's try another. Here and here. We're going to change the signs of everything on the inside. So negative 6 becomes a positive 6. And a negative 2g becomes a positive 2g. These guys don't change. And if I have 7 gremlins, 2 more come. That's 9 gremlins and 1 runs away. 8 gremlins. And 6. So as you've done this enough, you kind of fall into a groove, right? Now this is a tricky one. Study it for a moment and see why you think it might be tricky. So we have 2 sets of parentheses. I'm going to start with this one in the middle. Okay. This looks like where we would distribute a negative, but there's a negative on both sides, right? Well, this negative, remember, find a sign, draw a line to the left. This negative goes with the 9h. This negative goes with this. So this becomes positive 3h, this becomes positive 7, this comes down still as the negative 9h. Only it looks like a B, but it's an H, sorry. Here, what's being distributed here? Nothing, actually, because that negative went over here. So we're not going to do anything else with that, and it can only go there. So this 3h plus 1 just comes straight down. That would be kind of a weird way to see a problem, so I wouldn't worry too much about that happening a lot. Okay? Right, if 9 horses run away, 3 come back, that's negative 6. 3 comes back, that's negative 3 h's. Sounds like you need to build a better fence. 1 and 7 are 8. There you go. Cool. All right, we're gonna get this. Now sometimes for your distributive property, you'll get a positive out front. Okay. That means nothing's going to change on the inside. These are unnecessary parentheses. So this is a positive 2. Positive times a negative is a negative I. Nothing changed. Okay, so if I have 8 ice cubes and one of them melts. I have 7 ice cubes. 9, negative 9, add 2 back is negative 5. Nope, it's negative 7. All right. And here, one set's going to be changing signs. One set is going to have the same sign. So this becomes negative 6j and positive 6. This stays a positive 4j and a negative 8. So I distributed the positive, but it didn't change anything. All right. Negative 6 and 4 is negative 2j's. 6 minus 8 is negative 2. Good. All right. What do you think about the next one? If that positive is going in, it's not going to change anything, is it? So I just don't even need those parentheses. So I can combine my like terms. Let's see, I have negative 8k's and negative 2k's. It's negative 10k's. Hopefully that's not money. Negative 5 and positive 5 cancel each other out. I'm left with a positive 4. Remember, you don't have to do those in any particular order. Okay, 2 to go. All right, you see all that? My stinker boy used his hammer on my table. Kids. Okay, so there's those parentheses. It goes with a negative. These parentheses go with a negative. These parentheses go with a positive. See if you can do that first line. This becomes a positive 4. This becomes a positive 3n. This becomes a negative 5n and a positive 7. And these stay the same. These come down. Now I have a mess. I have m's and n's and constants. Again, I really think you should mark things as you go so you make sure you have everything. Okay. 8 monkeys. 1 runs away. That's 7. And 1 comes back. I have 8. If I'm a zookeeper, I'm happy. All right. Negative 5 plus 3 back is negative 2 n's. And now we have 4 and 7 make 11, less 9 is a positive 2. Good. So you can see the value in knowing the scale. All of this boils down to that, which is way more manageable than what we started with. Okay. Here is the grand finale. Go ahead on your own before me. Push play when you're ready. Okay, here we go. This set of parentheses goes with this positive because find a sign, draw a line to the left. So that positive is not going to change anything. Positive 3 minus 5q. Let's try this one. This is changing the sign of everything. Negative. Negative, negative is a positive. 8. Okay. This has already been used there, so this just comes straight down. And let's not forget about our friends that we left behind here. And then again, we have a mess. All right, variables come first. There's 2 of them to start from, or to choose from. P's come first in the alphabet, so let's do our P's first. 2 P's. And 2 more P's, or 4 P's. Look careful. Minus 7 is negative 3 P's. Okay, now we're on to Q's. A negative Q minus 5 more Q. Remember, this is subtraction, not multiplication. So if I'm in the negative and I subtract 3 more, I have negative 6 Q's. 6 and 8 are 14. 3 more are 17. 18, 19. Oop, I forgot this one. 19 minus 8 is 11. Whew, we did it. That was a long, long lesson. Thanks for hanging in there. I hope you found it really, really helpful. Okay, your homework for my class was broken down into pieces because this is a tremendous amount of work. I hope you've been staying on top of it. So if you will look at your notes and your homework, they go together. So the top questions for your homework go with the top side of the back page. Your bottom questions go with the bottom side of your homework. So if you're struggling with those, refer to your notes. If you need more space, feel free to use a piece of lined paper. Just make sure you write your final answer here. Okay? All right, I hope that was helpful to you. I really hope that was helpful to you. If not, please, of course, don't hesitate to send an email. And I'll be glad to help. If not, I'll see you in class. All right, good work, guys. Thanks for hanging in there. Bye.